this lesson 11-6, we're going to be studying about geometric sequences. And so just to kind of remind you, a few sections ago, we learned about an arithmetic sequence, and they have a common difference. All right, so the difference between the terms would be the same. In other words, you're adding the same thing every time or subtracting the same thing every time. That's an arithmetic sequence where that first difference is the same, right? Then, of course, we went on to study quadratic and cubic sequences as well. All right, so here we're going to be studying about geometric sequences, and the consecutive terms of a geometric sequence have to have a common ratio. So not a common difference, but a common ratio. So here's the definition of a geometric sequence. All right, so a sequence is geometric when the ratios of the consecutive terms are the same. All right, so if this is your sequence, okay, then if it's geometric, then there has to be a number r that's the ratio such that a sub 2, the second term divided by the first term, equals the third term divided by the second term, equals the fourth term divided by the third term, and so on. They should all be the same, and then that's your ratio. So r is the common ratio of the sequence. So consider for a moment this sequence. Let's say I have 2, 4, 8, 16, 32. And let's say that we were trying to figure out what kind of a sequence this was. Okay, so if we started taking our differences, let's see. So that would be a difference of 2, 4, 8, 16. Then the next difference would be 32. Well, what do you notice about that? You get the same number back again, right? The same numbers. So what if we take the third difference? Well, here 2, 4, 8, 16, 32. So there is no common difference no matter how many times you take the difference. Like, remember, if this was the same, it would be arithmetic. If this difference was the same, it would be quadratic. If the third differences were the same, it would be cubic, and so on. Well, you're never going to resolve this particular sequence like that because the differences give you the same set of numbers over and over and over. They don't go to the same difference no matter how many differences you go down, right? And so that can lead us to understand that when you take the differences, if they're the same like that, that we have ourselves a geometric sequence. So it's not the differences that are the same, it's the common ratios. In other words, instead of having to add the same thing every time to get to the new number, you have to multiply by the same thing every time to get the next number. So what would I multiply 2 by to get 4? Times 2. Alright, what do I multiply 4 by to get 8? Times 2. 8 times 2, 16. 16 times 2, 32, and so on. So we see that we multiply times 2 every time. So this is a geometric sequence, and the common ratio is 2. You multiply times 2 every time to get the next number in the sequence. All right? And so here's a formula for getting the nth term of the geometric sequence. Okay, it has this form: a sub n equals to a sub 1, the first term, times r, the common ratio, to the n minus 1 power. All right? And so again, this is kind of how the formula is derived. If you look here, it says every geometric sequence can be written in the following form. Okay, so the first number, the first term in the sequence is a sub 1. The second term in the sequence can be a sub 1 times r, right? Because you're multiplying times the common ratio to get the next number. So that means a sub 3 could be written as a sub 1 times r squared. A sub 4 is a sub 1 times r to the third, and the next one times r to the fourth, and so on. So you're writing out the sequence, all the terms in the sequence, in terms of the first term, all right? If that makes sense. And so from there, you know, it goes all the way up to a sub n, whatever term number you want, would be a to the first times r to the n minus 1, right? So if I want the fourth term, I take the first term times the ratio to the third power. If I want the fifth term, I take it to the fourth power. So it's just the power of the ratio is just 1 minus the term number. at that point. And then that is how you come up with the formula for a geometric sequence. All right. Let's see here. What else do we need to look at? And so right here, this is just saying whatever term you're at, if you multiply that by the common ratio, you get to the next term, the n plus 1th term. All right. Okay, so what type of problems are we going to be faced with here? Let's have a look. So what we want to do here is we want to determine whether or not the sequence is geometric, and if it is, we want to state the common ratio. Okay, so what we need to do is we need to take a look at the sequence. We need to see if it's multiplying by a common ratio every time, multiplying by the same number to get the next number. So to quickly try to verify that, 5 times what gives you 13 times 3. Alright, so let's make sure it works for the entire sequence. So what's 5 times 3? 45. What's 45 times 3 is 135. And so I think it's safe to say that this is a geometric sequence. Okay. And the common ratio is 3. Alright, so there you go. What about the next one though? Okay, so on this one, okay, maybe a little tricky. We start with 1, then we go to negative 1/2, then we go to positive 1/4, then we go to negative 1/8. So one thing that we do notice is that our sign is alternating. Alright, so is it possible with alternating signs in order to come up with making this a geometric sequence? Well, the answer to that question is yes. If the signs alternate, that could be caused by having a negative ratio, a negative common ratio, a negative value of r, right? Because if you multiply by something negative every time, it's going to change the sign every time. So it certainly is possible to have alternating signs on terms like this. That's possible. But the question is, do we have a common ratio, yes or no? All right, so now, once we get to fractions, sometimes it can be a little bit more difficult, but if you think about it like this, like what can I multiply 1 by to make it 1/2? Well, I can multiply it by negative 1/2, and then that would turn 1 into negative 1/2. But the key is, does that keep going for the rest of the sequence? Let's see. What if I multiply negative 1/2 times negative 1/2? 1/2 times 1/2 is 1/4. Negative and negative makes a positive, so we're still good. Try it again. Times negative 1/2. That would change it back to positive. 1 times 1 is 1, and 4 times 2 is 8. So I believe we have found our common ratio. It is geometric. Okay. And my common ratio here is negative 1/2. Okay, now let me say this. Okay, if you do get to 1 and it's too difficult to figure out in your head like that, what the common ratio is, remember, you can still get the common ratio by dividing this by this, right? Or any consecutive terms together, or dividing this times this, or excuse me, divided by this divided by this. That should all give you the common ratio. So if you get to the point where you just can't figure it out in your head by looking at it, then just take 2 of the common terms together and divide them out, and then see if the common ratios are the same every time. If they are, then you know it's geometric. So like right here, negative 1/2 divided by 1 is negative 1/2. Okay, 1/4 divided by negative 1/2. So positive divided by negative is a negative. And remember, you got to, when you're dividing fractions, you multiply by the reciprocal. So that would end up being 1/4 times 2/1, which is 2/4, which reduces to 1/2. So we still get the same thing. And likewise, if I did negative 1/8 divided by 1/4, that would be negative times a positive is a negative. And 1/8 times 4/1 would be 4/8, which is again reduces to 1/2. All right. So like I say, if it gets too complicated, which maybe it will once you get on to the quiz, you may have some that you just can't tell by looking at it what the ratio is. If that's the case, then divide out the consecutive terms, and then make sure you get the same common ratio every time you divide. That'll let you know that it is indeed geometric, and then the quotient of that division is the common ratio. Okay? All right. There is another type of problem that we are going to be looking at here, and this one says write the nth term of the sequence, okay, as a function of n. Write the nth term of the sequence as a function of n. And so remember, the nth term in the sequence is going to be given by this formula. It's on the other back of the page here. So it's a sub n equals a sub 1 times r to the n minus 1 power. Alright, so that's the formula that we are going to be using here. And the things that we need to make sure that we know in order to fill out that formula correctly is we need to know the first term, which we can get from the sequence. We need to know the ratio, which we can also get from the sequence, and really those are the only two things that we need, and then we'll have the answer. So on this first one, I'll have r sub n equals, the first term is 64, so we'll write that in. Alright, I want to see now if I can find the common ratio between all of these. 64 times 1/2 is 32, times 1/2 is 16, times 1/2 is 8, times 1/2 is 4. So I think we got our common ratio, it's 1/2. Now I need to raise that to the n minus 1 power, and we're done. Okay? So in other words, if I want the 1, 2, 3, if I want the third term, I can plug in a 3 here. 3 minus 1 is 2. Alright? 1/2 squared is 1/2 times 1/2, which is 1/4. And then 1/4 of 64 is 16, and I get the right term. All right, so that just verifies that I do have the right formula. Okay. What about the next one? A sub n equals. What is my first term? It is 9. Now let's see if we can find a common ratio here. Times 2 times 2 times 2 times 2. All right, so times 2 is correct. And that would be to the n minus 1 power. Alright. Okay, so the next one that we come to here, I know it's going to be a sub n equals, and I can go ahead and put a 6 in there because I know that's going to be the case. However, my common ratio may not quite be as easy to find on this one. One thing that I do know that I can go ahead and write is that it has to be negative. I do know that. And how do I know that? Because my terms alternate sign every time. The only, oh, you can't see that. Okay, so the only way that I know that it does have to be negative is because the terms alternate signs every time. So the only way that the terms can alternate signs every time, okay, is if I have a negative common ratio. Alright, so that's the first thing to make sure that we keep in mind here. And so the next thing is, how do I go about trying to find my common ratio? So that's the very next thing that we want to see if we can't try to accomplish here. All right? So how can we do that? Well, again, if you can't tell just by looking, which maybe you probably can, possibly by looking at 6 and negative 9, okay, but definitely, you know, once you get over to here, man, I don't know what to multiply to get back to this. Remember, you can always find the common ratio by taking a term and dividing it by the previous term. So if I want to figure out what the common ratio here is, I can take negative 9 and divide it by 6. Okay, so if I just reduce that thing down, then that's going to be negative, what, 3 over 2? And so there's your common ratio, negative 3 over 2. If you wanted to verify that, you could do it with one of the other terms. If you divided negative 81 over 4 by 27 over 2, guess what that would end up reducing to? Negative 3 over 2. Alright, so like I say, you can always find your ratio by dividing out two consecutive terms. Doesn't matter which two, you should always get the same ratio. And so now we know this is negative 3 over 2. I'm going to close that off and raise it to the n minus 1 power. And then, of course, that's all we need. We now have the correct answer. All right, and that concludes this lesson on geometric sequence.